Okay, here we go. Quick explanation and derivation of Heron's formula, also known as Hero's formula. It's the formula for the area of a triangle. Who could want a more simpler thing? But instead of a formula for the area of a triangle in terms of the base and the height, it's a formula for the area of a triangle in terms of the length of the sides. So this is great. If you give me just the three sides of a triangle, I can immediately tell you what the area of that triangle is, and without using any kind of trigonometry or anything like that. Well, the simplest derivation of this does use trigonometry, although you could probably avoid this with, well, you probably can avoid it. So let's go. What's the area of a triangle anyway? Well, maybe the simplest kind of thing to do is to drop a perpendicular and then to call this like h or something, and well, then there's this angle here, C, and so well, what's the area of this triangle then? The area, I'll do the fancy thing that people do. The area of triangle ABC is just well, it's 1/2 base times height. But h is then, since this is a right triangle, h is just a sine c. So the sine, well, I can even just write this over here if you want. The sine of angle C is h over a, so h is a sine c, and so you just get like 1/2 b times a sine c. And so this is even a thing that you just sort of learn, that the area of any triangle is in fact just 1/2 times the product of any two sides and the angle between them. Okay, so what can I do kind of with this piece of information? Let me just erase this now, because I don't really need to talk about h anymore. And okay, maybe put a little red box around this or something, and this is going to be our general strategy to find the area of a triangle. So I even want to find out what C is, but what the sine of C is. But I don't really have a direct ability to find the sine of C. What I can do is I can find the cosine of C, because I have the law of cosines. So what is the law of cosines? It's a formula for the relationship between the sides of a triangle and the cosine of one of the angles. And so, okay, what does it say? The most traditional form is to say that c squared is a squared plus b squared minus 2ab cosine c, where big C is that angle. I won't reprove the law of cosines or anything right now. That's one form. Maybe a more convenient form to write it in is just cosine c. So what's cosine c? It's just you kind of go zoom zoom zoom. So it's a squared plus b squared minus c squared over 2ab. And so now whereas I want the sine of this angle c, I have the cosine. So in some sense, I want like the sine of the angle whose cosine is this. Okay, and so you can mention inverse cosine, or you can just kind of draw a picture now or something. What does a generic angle look like whose cosine is that over that? Well, if the cosine is that over that, then that means I have to sort of label the sides of this triangle, or rather, I'm free to label the sides of this triangle in any kind of way I want. So I'm sort of making now a picture of angle C. What is angle C? It's an angle whose cosine is this ratio. And if that's the ratio, then perhaps the thing to do is just to let this be a squared plus b squared minus c squared, and let this be 2ab. So now this is a kind of a picture of an angle whose cosine is a squared plus b squared minus c squared over 2ab. And well, now I just can compute via the Pythagorean Theorem like the third side of this triangle. What's it going to be? Well, it's just going to be whatever the Pythagorean Theorem says it is. So it's going to be like 4a squared b squared minus this whole thing squared. I don't even want to write this, but I am, plus b squared minus c squared. So yeah, so in other words, I kind of use the fact about the cosine that it's in this ratio, and then, well, the third leg of the triangle is that. Okay, so here we are. I think we're just kind of ready now to do this problem. What is the area of triangle ABC? Answer, it is 1/2 AB sine C. So in other words, it's 1/2 AB, the sine of that angle. What is the sine of that angle going to be? Well, it's just going to be like that over that. And so I get this disgustingly horrible, I'll just write it as 2ab quantity squared minus a squared plus b squared minus c squared squared, that whole giant radical, over 2ab. 2ab. Okay, so really this is just a way of saying that this is the sine of angle C. And okay, we took this little detour into trigonometry. I'm wondering if we could have avoided it entirely. Well, I don't know. Maybe if I was being more cute, I could have done this in such a way that, eliminated all reference to sine and cosine, because it does feel like they've now disappeared, and they have. And actually, you could just stop right now, right? If the goal was to come up with a formula, an algebraic formula, so a formula involving only kind of square roots and sums and products and quotients and stuff, in terms of the three side lengths, well then I've already won. So I in some ways you could just stop now. And here's the formula, which if you plug in A, B, and C will give you the area of the triangle. But there are some simplifications and some kind of symmetry arguments we can make to make this a little bit prettier. So let's just do that. But the rest of this is purely cosmetic and aesthetic, I would say. Okay, so let's go. The AB's cancel, so that's kind of nice. And this leaves me with 1/4. Let me see. Let me try to patch this hole in my board. So this is 1/4 times, and what do we have? We have this big gross radical, this 2ab squared minus a squared plus b squared minus c squared squared. Well, we can now apply the difference of squares to this. So this becomes an even sort of bigger object, which is 2ab minus all of this, so minus a squared minus b squared plus c squared, I hope this is what I'm supposed to be doing, times 2ab plus a squared plus b squared minus c squared. And now that's 1/4 root. Okay, well, can I perform some even more simplifications? Well, I think I kind of can, right? Because these three terms remind me of a squared. Well, I'll just do it, right? This just is c squared minus minus b squared. Okay, that might be a little bit of a fancy move to kind of pull there. But of course that's just true, right? If you pull the negative out of these three terms, then you're left with a squared plus b squared minus 2ab, which is just a minus b squared. And once you've pulled that negative out, you can rewrite it as c squared minus. So hopefully that's not too fancy for my audience. Okay, and it's a little bit easier to see over here that this is going to be a plus b squared minus c squared. Cha cha cha. Okay, so maybe you want to introduce an extra line in there to do that a little bit slower, but I'm going to move on. This is also the difference of squares, and this is also the difference of squares. And so what we get is 1/4 times the square root of, and now we're really kind of almost done. this is C minus A minus B, so that is to say minus A plus B, times C plus A minus B, and then times A plus B minus C and A plus B plus C. And I now have sort of the square root of the product of four things. Once again, I'm free to stop at any point, but it is kind of nice to see this. Well, this is the perimeter. What's this? This is kind of the perimeter except with C subtracted out twice. This is the perimeter except with B subtracted out twice. This is the perimeter except with A subtracted out twice. So let's just do that. So this becomes sort of the perimeter minus 2A is this one. This one is the perimeter minus 2B. This one is the perimeter minus 2C, and this one is just the perimeter. And hey, while we're at it, let's stick that 1/4 back inside the square root, which makes it 1/16, and let's therefore divide up that 1/16 into 4 2's. Okay, so that was a whole bunch of things to do at once, but I'm making decisions based on how much board space I have, not on what's clear algebra. Anyway, it is now convenient to introduce this notion called the semi-perimeter. And okay, I have a love-hate relationship with the semi-perimeter, but of course the semi-perimeter is just the perimeter over 2. And, well, that makes it possible to write this as the semi-perimeter minus A times the semi-perimeter minus B times the semi-perimeter minus C times the semi-perimeter. And that is, that's the formula. The answer is that the area of any triangle ABC can be expressed as the square root of the product of 4 things. And so dimensionality, that sort of works. That you get kind of an area, and those 4 things are the semi-perimeter and the semi-perimeter minus. So this is perhaps just best thought of as well, I'll leave it at that. Okay, good. That's Hero's formula.